Hello everyone and welcome to this keynote speak, which is part of the third international conference of machine learning and automation. This keynote speak will be focusing on a particular area of research I am working on. This research is about AI-powered financial decision-making framework to predict stock price using LSTM algorithm and NLP-driven sentiment analysis model. This speak will be presented by me, Dr. Hisham AbouGrad. I'm a senior lecturer in computer science and digital technologies at the University of East London, and let me now move into more details about this area of research. So let me have an overview. Here we are going to have an introduction, talking a little bit about data and methodology, model architecture, and some key findings in general. So we know that stock market prediction is really important, especially in the area of artificial intelligence and financial technology research studies, and also in most industries in nowadays. And we know that sentiment analysis also has a significant impact and influences on stock movements. And this study integrates financial news sentiment analysis by collecting data about financial news with historical stock market data. And the reason behind that is to enhance financial stock market predictions. And by doing that, we enhance decision making in the stock market. So we know that sentiment data can be used, and the use of this can be with different ways. However, in this research we used, or this area, we have used natural language processing and API components, and these used to do the sentiment analysis. Also, we used stock market data mainly from NASDAQ, and we have integrated the data by giving scores through sentiment analysis and merged that closely with prices and normalization of daytime index. Our model basically is a multi-layer LSTM natural neural network model, and that model has been tuned with varying neurons, epochs, and batch sizes. And actually, we have done an evaluation using root mean square error and mean absolute percentage error, known as MAP. Also, we have used the R-square. These different methods used for evaluation of the model. And the contribution of this research include integration of sentiment data, which significantly has improved prediction accuracy. Also, highly effective short-term trend forecasting, especially for millennial investors. Our research demonstrates availability of combining natural language processing and deep learning in financial decision making. And that actually provide lots of promises when it comes to stock market prediction, which help investors. And so let me give a background about this research and the main areas and factors included in this research. So this research focused first about the importance of stock market prediction. As we know that stock market prediction is very important and it supports investment strategies and also financial decision making. On the other hand, it enhances market trend analysis and trading performance. Also, there are limitations usually of the traditional models that actually make us think about alternative solutions, because these traditional models depend primarily on historical stock data, and also it has failure to capture market sentiment and external factors. Also, identified research gap has been looked at, and we found that there is a lack of models that combine financial time series with real-time sentiment, and we find also that there is a need for a multi-source prediction framework, which is basically based on this literature. We start actually building this framework, which I will talk more about it later on. Also, we have proposed a framework and model architecture, and that's based on different studies, including studies that integrates historical stock prices with sentiment scores from financial conversations like Twitter or tweets. Also, sentiment scored using natural language processing based analysis, and the utilization of multi-layer LSTM neural network for capturing temporal dependencies and enhancing short-term prediction accuracies using key factors. And as you can see in table 1 here, which include key factors affecting stock prices, we can see that there are many factors, including market sentiment, historical prices, moving averages, price volatility, and also external events. All these factors used, and from the literature, it is really important to consider these different factors. And so I'm looking to talk about the research context. What's the context of this research? So we looked at different, as I mentioned before, factors. We looked at different use of techniques, including sentiment analysis, and also looking at historical data using deep learning. And first here, I would like to talk about evolving focus in fintech, or what's known as financial technology and artificial intelligence. And I already actually part of this research work. I have worked on stock market forecasting and looked at the challenges in artificial intelligence and financial technology research, which led to this research area and this research topic. Also, we find that traditional models, as mentioned before, neglect non-linear behaviors and market sentiment. And also there is a rise of deep learning and sentiment analysis enhances forecasting accuracy. Also, through the research, we looked at sentiment analysis in financial prediction, like natural language processing sentiment analysis, which is used for capturing stakeholder behavior and public emotion. And we know that through the news, we can predict a lot, especially that the news usually is alive, and we know that the stock market follow what's going on live. So sometimes looking at the historical data is not enough. We need sentiment analysis. We need to look at financial news because that's like the live news, because we know that the stock market depends on the current situation, and historical data cannot capture everything. So this will actually get rid of so many obstacles when it comes to stock market prediction. Also, the integration of sentiment with machine learning improves the performance in volatile markets, as I mentioned, and reveals non-linear market effects and short-term fluctuations. Also, when we use sentiment analysis, it will help us to boost investors' behavior modeling and market pattern detection, including, of course, decision making. Also, LSTM for stock market prediction is very important based on our study. We find this algorithm helps to capture sequential dependencies and complex patterns in time series data. And we find also studies related to that, as the study mentioned here. Also, we find that LSTM outperforms traditional models like ARIMA in financial contexts. Also, the combination of LSTM with sentiment analysis demonstrate that there is improvement in forecasting precision. And there are studies also support this. Also, the integration of LSTM and sentiment analysis makes a hybrid model which can look at the news and provide and achieve higher short-term prediction accuracy and effective during market volatility and chaotic periods, and bridges the gap between qualitative and quantitative financial signals. And therefore, what a methodology and methods used for the financial decision-making framework? Basically here, how we are going to achieve what we are looking to achieve. And so we have used different techniques and we build a framework model, proposed model with architecture, as you can see here in this figure, figure 1, which help us to do some experiments which help us to get into the results I mentioned before. So we looked at simple moving average, which is being calculated to enrich the data set. And this is being used anyway in different studies related to that. So we have input data, and that data helped us to basically run the model, and we split the data to training and testing, 80% for training and 20% for testing and validation of the model. And we have done the optimization using, as I said, this figure. So you can see we use data from Kaggle with tweets, sentiment analysis. We used stock data from Yahoo Finance. We merged the data set. We have normalized that. We split the data to training and modeling for validation. We trained the model and look at the testing and prediction. We have done a comparison and we get into the results. Here we have different batches used. We have sizes of 8, 16, 32, and 64, which are being used in this study. So, as I mentioned, we have done the normalization, looking at standardization of date time fields to make sure that there is consistency in the formatting of values. We have used feature engineering by calculating features like SMA30 and SMA50. We enhanced analytical value which is being provided to demonstrate comprehensive view of stock price fluctuations, improving the predictive power of the deep learning model. As you can see in this figure, this is the stock market closing prices of a year, and it demonstrates like the closing prices from 2021 11 to 2022 September, basically from November 2021 to September 2022. We have collected different data, as I mentioned, from Yahoo Finance, as you can see here, and also tweets. That's the tweet data, and the data in the tweets in similar period, 2021 November up to 2022 October. We have pre-processed the data to ensure consistency and cleaning the data, and also make sure that the data can be used in sentiment analysis and also for historical stock market data, which is being cleaned as well. We merged the data and integrated the data to ensure we get into the best results. That's our experiments and analytics figures, as you can see. We have done comparative analysis of prediction models where we looked at LSTM versus the traditional model, ARIMA. And we can see that LSTM has 12 to 15% improvement when you are talking about prediction accuracy. Also, we find that LSTM trained only on historical data provides 76% accuracy. However, we find that LSTM plus sentiment analysis has significantly higher accuracy. As you can see here in this figure, stock price trends over time, and it demonstrates from November 2021 to September 2022 how the price are going from the open to the close, and also high-low range. And we can see that from that data we get consistency through that, so there is no gap actually between these. Also, stock price trends over time has been analyzed. We have used Python models and tools like Panda for data manipulation and pre-processing, Skit-learn for feature scaling and performance evaluation, and Matplotlib for visualization of trends and predictions. Also, in our experiments and analytics, we have done actual versus predicted stock prices. And so you can see here in figure 5, the actual versus predictive stock prices. You can see also the results here from our initial prediction and evaluation. And you can see that for the RMSE, we get 8.0604. For the map, we get 0.02, higher percentage accuracy. And for the R square, we get 0.8174, which is about 81% of variance in prices. So what's our findings? You can see here that from the model evaluation matrix in table 2, that's actually our model performance matrix. You can see that for the R square, for example, we get 85, 0.85, which is about 85%. Also, for the mean absolute percentage error, we get 2.31%, and for the root mean square error, we get 7.25. Also, for the stock closing price versus sentiment score, as you can see here, we can see the differences, but we can see that sentiment score provide some differences which improve the accuracy when it comes to forecasting and prediction of stock prices. And that's what we are looking for, because such news it comes at specific time during the market, and it may change the market. So when you have such model, that will help speed up the process of prediction, and that help investors and investment to direct them to make the right decision. So in conclusion, we can see here that there are some limitations. Limitations include data set diversity. Also, we need to look at other factors, because we have lax integration of macroeconomic indicators. Also, we didn't account for economic shocks or crises. Also, sentiment analysis was based on VADR. This may miss subtle emotional core in financial text. There are further work and future enhancement. This include expanding dataset, integrating economical indicators, real-time feeds, explore transformer based NLP models like PERT, utilize multi-model data, apply reinforcement learning, and also it's good if that can be used other AI models like explainable AI, XAI. However, we can see from our study there is high achievements when it comes to the performance. We achieved 85% R square, and also we can see that the error is not really high. It's 7.25. So when it comes to decision making, we find that short-term market fluctuations can be adapted, and it can be spotted, and this will help a lot in decision making in financial market. Here are some key references which can be used. One of them is a related study I have done about financial decision-making AI framework to predict stock price using LSTM algorithm and NLP-driven sentiment analysis model, which is similar to what I'm talking about here. Also here are other related studies like investment strategies and also stock price prediction using news sentiment analysis and so on. I would like to thank you for your attention here and listening to this keynote. Hopefully you find it really useful. Thank you, and I wish you all the best. Thank you very much.